We are here with the scanners. In this point, you're farther. There's going to be a transition. There's going to be a transition of institutions that invested heavily in the scanners are still using them and leveraging as much as they can leverage it. But then they're seeing this next thing and that is better. And then on one hand, how do you justify abandoning all this investment? On the other hand, how do you justify continuing doing something that's less efficient than it could be? What are your thoughts on that? With the phone, it's something everybody can afford, more or less. Yeah. You just ditch the other phone and take the new one.
Yep.
Let me know what you think about that.
Learn about the newest digital pathology trends in science and industry. Meet the most interesting people in the niche and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
Welcome to the podcast, my Digital Pathology Trailblazers. Today, in this episode, my guest is Prasanth Perugupalli. He's the Chief Product Officer of Pramana. Pramana is a digital pathology company that is on a mission to revolutionize digital pathology. But, are not all companies on the mission to do that? But Pramana has a unique aspect to this, and we're going to learn in which way Pramana is going to revolutionize the digital pathology market. Welcome, Prasanth. How are you today?
I'm very well, Alex. How are you?
I'm good. Thank you for joining us. We always start with the guest. You're our guest of honor today, so tell us about yourself. Tell us about your background, and then tell us a little bit about Pramana, a little bit more than I said.
Thank you so much. I'm an electrical engineer by training. In early part of my career, I've been a designer, I've been a product manager, mostly in the semiconductor world, looking at early generations of cellular radios and such. So signal processing has been something that I've been close to. And as some sort of a natural consequence, I started getting into image processing. I work as a chief product officer for Pramana. We are about a year and a half old as a company. And you talked about trailblazers in digital pathology. We are trying to bring a version of digital pathology that is more for the masses, trying to make it in a fashion where it is not necessarily a trailblazing technology anymore, but what it takes to be able to put it in the market, in the labs, and in the hands of people that want to use it, and be able to do it confidently.
So I call my people, those who listen to this podcast, trailblazers, but also my guests are trailblazers to me. I call us all trailblazers because this technology has to wedge itself into the healthcare system. Everyone who's making this happen to me is my fellow trailblazer, and especially if you're trying to bring it to them. So let's go into Pramana. How did this happen? And let's maybe talk about it in conjunction with how did you move from being an electrical engineer to electrical engineer working on images and then on images in the digital pathology?
A little bit of a history. I was in the US working with large corporations in the wireless space for about 15 years. And at some point, we had decided to move back to India. I had the unique opportunity to work with a research organization that was putting together some early days of looking at how we could utilize images in the medical space. This was an organization from Europe that I was heading. And I had a very, I would say, pure by stroke of luck. I think I met with a bunch of guys at the time who had come from LG and GE and a few other such organizations. All of us had one zeal in mind, which was to say, could we build some kind of a system that has software, that has pieces of optics and hardware. And we built our startup back in 2016, a company called Spectral Insights that was built out of Bangalore in India. We were very clear about essentially utilizing the aspects of software, computation, and math in conjunction with the hardware elements to say, could we build a true software hardware co-design, if you may, which allows us to be able to solve a problem across any part of the stack rather than being pigeonholed. I would only build hardware. I would only build software. This was a journey that we started in 2016. And in 2019, just about when COVID was hitting us, Inference, which is a company based out of Cambridge, Massachusetts, a data science company, which works in the realm of text and data analytics and is accumulating solutions that allow you to do a lot of multimodal data analytics. Inference was looking for a partner to add imaging to its table. Inference acquired us 2 years down as we were building these systems further and going into our early customers and such. We realized that co-design between software and hardware was gaining a lot of momentum as we approached, was starting to realize the value.
Showing a smartphone here for those who are watching on YouTube. That's like ultimate thing of software and hardware coexistence.
Exactly. And so we were able to actually address a lot of the problems that the industry has been talking about for 10 years. And we got a tremendous amount of encouragement from the trailblazers, some of our very early research collaborators at Mayo Clinic and such. And we realized that this technology is actually getting very ready now for prime time. So Pramana was formed last year as a spin-out of Inference. And we went on to independently build an organization with its own sales force and with its own legs, such that we're able to bring the digital pathology technology that we've been building to the markets.
So a couple of aspects that are unique already in your journey is the hardware-software merger, so to say. I'm showing the iPhone because in like real world and the Internet of Things is basically taken over stuff. But in digital pathology, like you mentioned, there is software companies, there are hardware companies. So there is the need for merger.
Yeah.
So you have that, and you have the parent company who's a data company. Yeah. Now it's not just images. Before it was, okay, a pathologist looking at an image and there is data, that's a report, but how do you like extract anything quantifiable from the report? Now with all the algorithms with image analysis being done on whole slide images, there is a bunch of data. So this is like a triple merger, software, hardware, data science.
Absolutely. And it's fascinating. When you start looking at it in that realm, what you realize is that there are opportunities just purely learning from reading growth section notes to figure out what may have been the thought process behind that in terms of the slides that were created, the blocks that were cut. The aspect of being able to merge text and text analytics with what happens with your hardware to be able to take advantage of inputs that can feed in directly to the acquisition system. And the ability to say during that process, are there things I can learn in line that then can be utilized to be able to enrich the data further? When you start doing that in a fashion, just the way you described the iPhone, you realize that as you use an iPhone today for making images, the iPhone even lets you actually make some choices to say, what object do I want to focus on eventually? You could imagine there is an analogy that could be happily built in the pathology world. And that's the beauty of the software hardware co-design. And we are, I think, one of the earliest guys who are trying to harness that. And a bit of that comes from, I think, my own past history and background, where I've had the opportunity to work with some very cutting edge Wi-Fi technologies and such. And we were looking at how a particular new Wi-Fi chip could get embedded into a brand new MacBook and what are all the things that it can do to the user. So this is a similar pattern in which we've been going about doing what we do. And it's starting to show some interesting outcomes at this point.
Totally, definitely. I have to laugh always because I show a smartphone and you say iPhone, I know you're from North America. Because in Europe, not so many people have iPhones. So I have to smile about that. But now, in all seriousness, back to our topic. So you have like this holistic approach. You have the technology, you have the data science expertise. How did it happen that you ended up in digital pathology? Did you go through a list of, relevant areas where you would want to apply it? How did you end up in digital pathology? Why digital pathology?
That's an interesting journey for us, Alex. When we were part of this research organization, especially around spectral imaging and hyperspectral imaging, we were trying to look at what are all the various kind of things we could do with hyperspectral imaging. We had looked at fundus imaging as an example, and we had looked at imaging leaves by flying small cameras from a little bit of elevation. And we were doing foot imaging and such. And interesting enough, one of the problems that we had come across was looking at blood smears and detecting malaria parasite. And actually, hyperspectral imaging was a very good candidate to be able to pick up small traces of falciparum.
I have to ask a layman question. Tell me about hyperspectral imaging. What's the principle of hyperspectral imaging?
Essentially, with hyperspectral imaging, unlike in the bright field imaging, you're looking at the aspect of shining wideband light, but then picking up data at various wavelengths through the use of filters and such, that you're not only picking up the notion of color, but also the aspect of what the behavior of the specimen is, the actual content of the specimen towards various kinds of light. And it opens up a whole new space that I think is imminent to happen in digital pathology as well at some point. So someone had introduced us to the problem of looking at blood smears and detecting malaria, but then we also realized that the industry worldwide wasn't yet adopting digital pathology, digital images by themselves for their routine work. So adding the aspect of spectral imaging to bright field would have made it a lot more of a challenge to be able to convince anyone in the field. And we quickly realized that we had to go one step at a time. There were cases where we had come across in India at the time where organizations had spent a lot of money to buy these expensive whole slide imaging scanners, and they were collecting dust because either people didn't know how to use it, or the requirements that were put on the labs to say, thou shalt do so many different things in order for the scanner to work were just daunting. And what originally started out saying, we want to solve a problem in malaria, became a mission to say, looks like the biggest opportunity is to actually build a very heavily software-driven system that takes away the enigma of how I would go digital in a lab.
What was the biggest surprise, or like the biggest, like you did not expect this in pathology lab when you weren't there? What was the surprise for you?
I would say
Or something, why is it done like that?
I had an immense amount of respect for doctors growing up. In India, you would either be an engineer or a doctor, and those who cannot be doctors became engineers. But the biggest surprise to me was the fact that there were about, in some cases, 12, 15, 20 slides that someone was going through, but it all resulted in one report. It told me that somehow in the mind, there is a memory element that was being built up to be able to read through all of these and continuously go about building a case and being able to write a report. And that was, to me, more than a surprise. My respect for pathologists went up so much when I saw that. Of course, the immediate question was, then why wouldn't you use digital? And it appeared to me at the time that it should be possible to use digital and put all of these on the same screen, on a very large screen, and look at them. And then we realized that the labs were struggling to be able to actually go digital at all for a variety of reasons. One of the biggest things was just the price points. But more importantly, I think at the time I had realized that it would be so difficult for them to change their processes, or they have to adhere to so many different things in order for getting good images. It felt that there was the opportunity to say, if I brought in a bunch of image analytics or image processing onto the place where I'm making images, a lot of the problems can be solved in a much cleaner manner. So that was our impetus to get going, and we see that today. Everything that Pramana is talking about today is all about saying, how do you liberate the technician, the lab manager, and the pathologist from having to get retrained or look at what kind of compromises they have to make, either in terms of their own work style, workload, or compromises in terms of what they are offered on a screen to make a decision. That's what Pramana is trying to achieve, to address today. The aspect of making it easier, if you may, for anyone in the ecosystem to say, I can achieve digital, both from a technology perspective as well as from a commercial perspective, the cost of getting there and such. And in the next generation, we are now looking at how much more enriched data can be generated from these systems, which again is a next generation element to digital.
So I was sighing when you said that those scanners were collecting dust. I have this vivid picture in my mind. My PhD was funded by a scholarship, and with the scholarship I went to Ethiopia once to visit a pathology department, and there was my co-scholar. We all went to for the scholarship to Germany, and he just finished his scholarship. He got his PhD. There was some kind of grant that bought all the lab equipment, PCR equipment for this lab. It was a fully equipped lab. He was there as the future lab director with all the know-how from Germany. Everything was collecting dust because the reagents were too expensive for that hospital.
Yeah, absolutely.
And it's like, when you said the scanners were collecting dust, I'm like, yes. And how much of this stuff is happening across the world, across science, across healthcare? So I am super excited to hear, how are you going to give the market, give the digital pathology space the next generation? What are you guys offering at the moment? When somebody wants your thing, what is it? How can they benefit? And how is it done technologically different than it was in the first generation way of scanning and doing digital pathology?
We've been talking a lot of late about a second generation of scanners. And essentially, it is to say that scanners should become intelligent enough that they are able to figure out what kind of a specimen is offered to it, what may be all the things that can generally happen in a lab in the due course of how work is done, whether a cover slip is not able to be placed perfectly well or a label sticks out, or for that matter, a microtome is just a little bit out of calibration and you don't get perfectly well-made slides. The aspect of saying how scanners can be made more intelligent and more aware through the use of algorithms, through the use of sensors, and take away the burden from the technician, as an example, to say, should I load this sample in the scanner? Should I not load it? Should I have to make some choices in terms of whether it is focus sample points or Z-stacks and various other elements? But the ability to say, why couldn't you build a fault-tolerant system that is able to detect things while the slide is still inside the scanner and with a little bit of a differentiated parameter set, just like how you would expect a technician to do that, can technically be learned by the scanner. And the element of essentially building a capability that takes away the human dependence is what we've been talking about as our second generation digital pathology system. This we think is the second generation for the industry. What we are offering today is essentially a full-fledged solution that allows us to be able to bring in our scanning systems, our software, and deploy it at customer premises, and essentially be able to give confidence to the customers that they could literally hand us their slides and we would essentially give them back assured, fully quality tagged images in a standardized format and back into their storage space. How are we able to achieve that is through the aspect of, we don't have armies of people running these. In fact, we have a lot fewer people than what a customer would normally expect to have while they go digital, which, by the way, is an area that is heavily discounted in general. Folks understand only after they bought the scanners and want to go digital how much of a human intervention is needed. Yes.
Everybody's talking about, pathologist and the image and its equivalent or non-inferior. And I have not yet seen a paper. Maybe I should read more papers, which is my resolution for next year, but something focusing on the previous work, the pre-viewing workflow, pre-evaluation workflow. And you even mentioned grossing. Like, I have heard this there, here and there, but not really, this is not really a full-fledged discussion yet, how to start there. And maybe when we are already there, there is another step ahead that we can, I'm not even talking about all the pre-analytical and standardization of fixation and all this stuff. Like, that's a topic for a different discussion. But yes, definitely, this is a heavy burden on the staff operating those machines. And
so we have addressed that through building software. The current flagship program that Pramana is involved with, which is, in my opinion, the single largest digitization program that is happening at Mayo Clinic in Rochester right now. Almost 10,000 slides of scans happening every day and being really manned by two people. Mm-hmm. And so the element of being able to achieve a highly efficient scanning operation, which includes all the way from essentially saying, I take the slides as they come through, no pre-assessment of what is on the slide, no cleaning of the slides, no assessment to say, is the label sticking out and things like those. all the way here is the quality tag that says this much percentage of fields are potentially having a soft focus on the slide. All of this being done completely in an autonomous manner is what we've been able to build and deploy it and run it now for several months. And so we have now, I think, proven to ourselves and to our customers that this is actually possible.
So you are running a massive archiving project at Maya Clinic, and I recently had a guest from Maya Clinic, Dr. Rishpai, who was also involved in the digital pathology initiative there. Okay, so let's talk a little bit from the business perspective, service versus product. What you're offering now is you have your product placed at the customer site and you're offering this service or as this archiving service. Why that? And is that going to be the model? How is this benefiting the clients?
That's a very interesting question. The reason to offer service, as in pathology as a service, which results in customers not having to worry on their end, their resources and training and retraining and compliance.
Just want to emphasize something, because digitization of slides is a service. You can send it to somewhere and they will scan it for you. Your service is different. You come in with your machines, which for YouTube, I have to include a clip how the scanner looks like. It's a different looking scanner. Whenever you guys look at it, you will not think it is a scanner. For the longest time when we were talking with you and with the team, I was like, units, they're probably like different objectives within a box. It's nothing like a box. But yeah, so the machine is placed at the customer and your people are doing their job at the customer site. So there's no disruption to whatever is happening in the hospital. And that's different.
The aspect of customers, whoever we have talked to in the early phase, we felt the biggest impediment for them to go and do something at scale was just the fact that their early trials and their early experiments that they have done, pilots and such, resulted in a situation where I don't think anyone had the confidence that they could do things at scale. They were worried about all the issues that they ran into. And so when we went to our customers, early customers, and made an offer to them saying, we would take it on our chin and essentially literally have you give your slides and then we'll give you back digital outputs that are fully QA assured, that are DICOM compliant and such. It was more to actually lower the barrier for the customers than anything else. It was to give them assurance that we are able to do that and also to be able to do that at a very commercially viable price point.
Especially if somebody already tried, invested, and then justifying like trying out again for the same amount of money, there's going to be a big pushback.
So something had to be different. So we had to innovate. And I think one of the innovations, which actually is gaining a lot of interest across the US, is this aspect of saying that customers don't have to make capital commitments upfront to buy these systems and also have to decide on how many times a year would I actually get a service call. My way to look at it, Alex, is we are in the earliest phases of digital scanners. They are going to dramatically change over the next couple of years. So the ability to convince the customers that they shouldn't have to make these calls and actually buy these systems that will essentially very soon become bricks over the next 2 to 3 years, if you may, was actually something that we realized was a real need to address. And so our vision was right on to say, how about we demonstrate our confidence in being able to do the digitization the way we are claiming it can be done by essentially walking the talk and saying, we can do this on our CAPEX and you pay on a pay per slide basis. And it is starting to work beautifully. One of the biggest challenges that we had to deal with, I think, more than just the aspects of operations and how we thought it would run, is just the variety of specimens that come your way. Interesting enough, the variety is less about the tissue, but more about the aspects to deal with the labels and the IT system for a particular year being different from some others. And sometimes ink has flown over a 2D barcode and hence you cannot decode it anymore. There are lots of interesting challenges. Now, the business model that we've been able to put out there is essentially to take away all that friction. We are able to go back and tell our customers that we can continuously improvise and adapt to newer challenges as they come with newer sets of slides from different departments, or sometimes it is slides that are coming in from other locations for second opinion and which have a whole different type of syntax, if you may, and how the slides are made and how they're handled. We've been able to demonstrate that the intelligent systems concept is able to be resilient enough that it can actually adapt very well. And customers don't have to change their budgets. They're not caught by surprise. They are aware that the cost of going digital for this many slides in a year is going to be about this much. And they don't have to worry about maintenance contracts and how long before a service professional shows up. Most importantly, we are offering the ability to monitor and handle any kind of challenges that the customer might face. The part about essentially taking away the pain of making images from the customer and using a wide network that could be worldwide in nature, that is taking learnings from various locations and being able to address day-to-day challenges that will happen on the field. That is where I feel the industry has to move. The end point is not scanning. The end point is way downstream. And the aspect of making images, handling images, enriching the images with whatever data you can should almost become a table stake element.
And you said the sentence, the endpoint is not scanning. When the endpoint is scanning, people don't see the value of digital pathology.
Exactly.
Because, okay, if we have a pathologist who can do the same on the image, on the microscope, faster, without system, without upload, download, like what's the differentiator if the digital and the glass are non-inferior?
Yes.
That means glass is non-inferior or the same, so let's keep doing glass.
Yes.
And so far, the added value was image analysis. Image analysis in terms of quantification in the simple form of IHC quantification. Then deep learning came to the scene and the prediction models were being built. So this is still like a huge added value.
Absolutely.
But there's a lot of stuff that is not being addressed, like tagging, like the QC, and like everything that like in between that happens between the scanning and all these fancy insights that you can get with your fancy algorithms, or less fancy, whatever. I love image analysis. That's my background. So anyway, but yeah, this is definitely something different, not addressed. I want to ask you, because when you're saying about this, we are here with the scanners in this point, you're farther, there's going to be a transition. There's going to be a transition of institutions that invested heavily in the scanners are still using them and leveraging as much as they can leverage it. But then they're seeing this next thing and that it's better. And then on one hand, how do you justify abandoning all this investment? On the other hand, how do you justify continuing doing something that's less efficient than it could be? What are your thoughts on that? With the phone, it's something everybody can afford, more or less. Yeah. You just ditch the other phone and take the new one. It breaks, the glass breaks, you buy a new phone now.
Yep.
Let me know what you think about that.
It's very interesting the way you describe the phone. Of course, scanners are much more expensive. However, at some point, technology is going to have to drive the next generation decisions, because when labs and hospitals and institutions are talking about digital today, they are talking about holding the digital images for a while. Algorithms are being built not for today alone, but for going well into the future. And one of the challenges that you always have with early adoption technologies is that things work to a certain point with a lot of compromises. And then there's got to be some inflection point somewhere where you say, everything I do needs to be future-proofed, and I have to make a choice. And I'll give you a perfect example. Millions of slides have been scanned, and they don't know what is the quality of the data that is actually in their storage, because it has been too expensive to go back and open them up and check to say, what do we do with these? Do they have to be rescanned? Or even to go in and say, this is an area that I should not have used for my algorithm. So at some point, you have to make that choice to say, yes, it is a sunk cost versus how long before all this data would start to become not so attractive anymore because technology is changing. You have to make a choice at some point. you have to look at the aspect of what is the new technology bringing. When you start to get to that point where you're able to make such calls, there is new data getting added. So with new data, algorithms will evolve, and I think they will go to higher level. The challenges that the algorithms have to solve will change. The thing is, when pathologists have been able to use glass slides in whatever form they got to make their decisions, if algorithms are getting constrained in terms of saying we cannot achieve that, you have to realize that technology will continuously evolve towards that new phase. And customers have to be wary of that. And that is indeed why when I talk to a lot of customers, I'm openly telling them, I think you should stop buying scanners anymore, because technology is going to change. For a long time, things were at a very slow pace, right? But now you see digital taking off in a fairly large fashion. And a lot of it is driven by algorithms, like you said, and just the aspect of having a whole new appreciation for telepathology and various other elements. But as it is catching more tailwind, technology is going to evolve faster. And as it evolves faster, you have to continuously keep moving. Gone are the days when you keep your phone anymore for 5 years. So it's the same situation that you are going to move into. And what does that do? It results in new business models. And that's indeed what we are talking about, which is please don't pay for
that is basically the definition of innovation. You move with the world. And like when you said, okay, there's not a way to keep the old stuff. And I thought when you were saying those old scanner, I reminded myself, I have the picture. How many cameras? I have, I don't know, 6. Yeah. Include maybe 8, because including 2 non-digital cameras that I have.
Yeah, so we see that. And one of the things to talk about from a technology perspective as an inflection point, I think from a intelligent scanning and intelligent, I would say enrichment, data enrichment, is what I think we pioneered. I think we were the brave guys to go out there and look at how to do this right, which is to say, how do we do volumetric scanning? Scanning in a similar fashion as how any pathologist would use their microscope in a fine focus mode. And that actually changes the paradigm quite a bit. So it is truly a big change, a step function. So it is good enough of a reason, in my opinion, and I don't want to sound like I'm a sales guy trying to sell Pramana's scanner. But I think
project, you believe in what you guys are doing, so totally go ahead and be 100% behind what you guys have.
More so than anything else, it is actually very good for the industry when you're able to say that all the impediments, all the problems that the industry has seen as people have tried to tinker with the early systems can actually be solved in a very nice fashion. The second part of it is then also the appreciation to say on a daily basis, there are going to be challenges with specimens in the lab. It is easy to say that a technician should be more careful and you can invest more money in a more advanced cover slipper and have different ways of printing labels onto slides and things like that. In the general scheme of things, when you talk about beyond the early adoption elements and mainstream adoption, you have to cater to the masses. And to cater to the masses means that you have to solve a lot of problems as they occur in the labs. And one of the things that we've been able to do extremely well is this aspect of using robots in a fashion that haven't been done before.
I'm smiling because I have seen a video of your robot and it's the most hilarious thing. Exactly. I hope we can put this on YouTube as well over this.
Automation and computation can change things. You're going to see a lot of changes coming there as well from us as well as from many of our competitors. So all in all, the aspect of when it comes to business models, the element of saying this technology now is at a point, it can be essentially treated like most of the other lab equipment. We also recognize that there are some customers that will need a different way of looking at things. So we are starting to build ecosystem partnerships and distributor partnerships and such where we can offer things at various other strata as well.
I'm really fascinated. I'm looking forward to hearing more about your technology being brought to the hospitals. And I know we're going to be talking again. So before we go today, before we finish, let us know where can we find more information about Pramana? And the second question, which is the next conference you're going to be at so that people can talk to you and ask about that?
You can obviously visit our website, www.pramana.ai, and you will find a lot more information and some videos and such these days. I will be at the Global Engage. We do plan to be at the US CAP in March. A fairly large presence with some new products that we're going to be demonstrating, some very interesting new visualization engines that we are seeing a tremendous interest from customers for. So really looking forward to bringing some interesting things out there and showing them at the US CAP.
Fantastic. I'm going to link to your website in the description. And my New Year's resolution is go a little bit more on tour on the conferences and actually play with all those things that you guys are telling me about on the podcast and touch them and talk to your people. So I'm super excited about that. Thank you so much for being my guest and have a great day.
Thanks very much, Alex. You too. Have a nice day.
Thanks so much for listening. Be sure to check Pramana's website, and on their website, if you go to products, you will see the image of their scanning units that look nothing like a classical whole slide image scanner. And if you find this podcast valuable, please share it with someone who you know would find it valuable as well. This helps us grow, and I very, very much appreciate it. If you want to take part in the discussions, go ahead and connect with me on LinkedIn, and I talk to you in the next episode.